Of the Gizmo, we were investigating how mass and volume affect sinking and floating as we are trying to just add to our understanding of the concept of density. Remember, the Earth is layered because of density differences between the layers. The more dense layer is toward the center of the planet, and that would be our core, and the least dense layer would be the top layer of planet Earth, what we live on, the crust. I wanted to take a couple of days to just mess around with the concept of density to make certain you really understand, because it isn't going away, it's going to keep on coming up. So density is the amount of matter in a given volume, or the amount of mass in a given volume. The Gizmo had you investigating those two properties of matter, mass, and volume. And one of the big questions Gizmo asked was, can mass alone predict whether an object will sink or float? In the perfect example in the Gizmo, you investigated a whole bunch of different items. Two of the items that you investigated was a ping pong ball and a penny. And we had to mass these objects out. In the Gizmo, we found out that a ping pong ball has a mass of about 3 grams. We also found out that a penny has an equal mass of 3 grams. Now remember the big question, does mass alone help predict whether an object will sink or float? Well, here's a perfect example. Let's take a look at these two objects, the ping pong ball and the penny. When I put the penny into the container of water, it immediately sinks to the bottom. Yet, when I put the ping pong ball into the container of water, it floats. So if you have two different items with equal masses, one sinks like the penny, the other floats like the ping pong ball, ask yourself, can mass alone determine whether an object sinks or floats? I think not. So the answer to that is no. Mass alone cannot determine whether an object sinks or floats. Moving on, let's take a look at the second property of matter that is part of what density really is. Remember, density is the amount of matter or mass in a given volume. Remember what volume is. Volume is simply the amount of space an object contains. We can all often think of volume as the size of an object. Okay, so the bigger the size, the more space the object contains. Here I have two stainless steel spheres. This sphere has a volume of about 22 cubic centimeters. This metal sphere, both stainless steel, has a volume much larger. This is about 1,047 cubic centimeters. So I have a stainless steel sphere with a small volume, a stainless steel sphere with a larger volume. Now let's investigate whether volume alone can help determine or predict whether an object will sink or float. Let's take the small sphere. Let's put that in the container of water. You can immediately even hear how quickly that sank. That stainless steel sphere sank very quickly to the bottom. Remember, that has a smaller volume of about 22 or 24 cubic centimeters. Now here's the larger stainless steel sphere. This has a volume of over 1,000 cubic centimeters. I'm going to put that into the water, and that floats. So let's ask ourselves, can volume alone determine whether an object sinks or floats? Two stainless steel spheres. One with a much smaller volume, takes up much smaller amount of space. One with a larger volume. One sinks, one floats. The smaller volume sphere in this example sinks to the bottom of the water. The larger volume sphere floats. So can we use a volume alone to determine whether an object will sink or float? Think about it. The answer here is absolutely no. We cannot use volume alone to determine whether an object sinks or floats. So that brings us back to the big concept of density. Density is the amount of matter or mass in a given volume. Can we use both mass and volume together to determine whether an object sinks or floats? Today, in Part B of the Gizmo and C, you're going to investigate the property of density to further support your understanding as we move on and learn about each of the layers of the Earth, the crust, the mantle, and the core, a little bit individually, and apply that big concept of density.